For day 90, we are asked to solve the following inequality that involves absolute values. So the way to go about this is as follows. So first of all, we're going to find critical values by first making each of these equal to 0. So 2x minus 3 equal to 0 can be solved to be x equal to 3 over 2. And x minus 4 equal to 0 can obviously be solved to be x equal to 4. Now, 3 over 2 and 4 are critical values. So on the number line, we can break this inequality up from negative infinity, not inclusive, to 3 over 2, not inclusive. And if we take a number that's in this interval, say for example, a large negative number, this is going to be negative, and this is always also going to be negative. So in order to make it positive through the absolute value, we're going to distribute a negative. So it'll be negative into 2x minus 3 less than negative x minus 4. Now we distribute this negative and we get negative 2x plus 3 less than negative x plus 4. And now we solve for x. So we take this, or let's rather take this negative 2x across that way. And then we have x, because negative x plus 2x is just x. We take that 4 across. 3 minus 4 is going to be negative 1. Now we take the intersection of this and this to find the actual inequality that exists in this region. So it'll be from negative 1 less than x less than 3 over 2. Less than, not less than or equal to, because it was not inclusive here. And then I don't include everything from negative infinity to negative 1 because it's not included here. So this is simply what's included in both. So for that part of the inequality from negative infinity to 3 over 2, this is our solution. So now we do the same between these two values, and then we're going to do the same to infinity. So let's do the same for in between these two values first. So now we're going from 3 over 2 inclusive this time, because we didn't include it here, all the way to 4. So now, if we take a random value between 3 over 2 and 4, let's say 3, we'll notice that this part of the inequality will be positive and this part will be negative. So therefore, the absolute value will not have to distribute a negative here, but it will have to distribute a negative here. So now we can solve for x. So we take this negative x across, and we get 3x less than, take that negative 3 across, 7. So x is less than 7 over 3. Now once again, we take the intersection of this, and what we're left with is simply from 3 over 2 to 7 over 3, because 7 over 3 lies in this interval. And we have to be less than 7 over 3. But then again, it's what's in common still with this. So it's from 3 over 2, inclusive, so less than or equal to x, less than 7 over 3. All right. So now it's just the last interval, which is from 4 to infinity. And if we notice that we take any large number that's greater than 4, this will be positive and so will this. So what we'll be left with is, in the interval from 4 to infinity, what we'll be left with is 2x minus 3, which will be positive, less than x minus 4, which is also going to be positive. Now we can take our x across here, and then 2x minus x is simply going to be x, less than minus 4 plus 3, which is going to be minus 1. Now we take the intersection of these two sets, and now we notice that x is an element of the empty set. In other words, the intersection is nothing. There's nothing that's in common between these two sets, since negative 1 is less than 4, and we're asking for numbers that are less than negative 1. So obviously it's an empty set. All right. Now, with all these sets that we've boxed here, we have to look for the union of them now. So the empty set union with anything doesn't really solve anything, but we have to look at the empty sets of these two sets. And what we notice is that we can go from negative 1 all the way to 3 over 2, and then we include 3 over 2 here, and then we go all the way again to 7 over 3. So our final answer to this inequality involving absolute values is going to be negative 1 less than x less than 7 over 3. And don't forget, this is where x is an element of real numbers. Thank you.